Good evening, guys. Today we are going to go over, and you're going to add into your notes, how to simplify and evaluate rational radicals and exponents. We're really going to focus on the simplifying part because once you get simplifying down, you should be able to evaluate. All right, so make sure your notes are open and you're ready to go. Remember, as you're going through your notes, you're tiling it. You're adding in that essential question. Our essential question is, how do I simplify rational radicals and exponents? So you're focusing on simplifying because you can evaluate after we're done simplifying. The first thing we need to talk about is this nth root. What does nth root mean? And you're just now starting to get into this terms of nth, and it's going to continue with you forever. So nth root, when b to the n equals a for an integer, remember integer, it goes whole number, then it goes integer numbers, and then it goes rational numbers. Okay, integer number n greater than 1, positive or negative whole number greater than 1, b is the nth root of a. This b is that nth root. B is the nth root. Okay, your key idea for this for this lesson is converting from this form to a fractional form, a rational form, and being able to go from a rational form to a cube root, or really it's called an nth root. All right, if you didn't get all of this down, pause. If my writing's starting to get in the way of your writing, rewind and listen to this again. Just make sure you have these key terms because we're going to work with them in the next couple of slides. All right, the simplify for the 6 problems here should really say evaluate. We're going to go through these 6 problems and get that number answer. We're not going to keep it as a power like you see in number 4, 5, and 6. And we're not going to keep it as a radical. We're going to get what number will you have when you actually go through and finish up the operation. Remember that square root, cube root, the 5th root, the 4th root just means what times itself, n times, gets you that number that's in that radical. Okay, I'm going to go through and erase this so we have more room to work with. Okay, so again, not simplifying, we're getting that evaluating. All right, number 1, 2, and 3 you can do on your own. You don't really need much help, but I'll review with number 1. Number 1 saying what number 3 times, this 3 right here, will get us 216. I know that if I did 6 times 6 times 6, I will get 216 because I did this problem already. And so our answer, our evaluation of what is the cube root of 216 is 6. That's your answer. Go ahead and do problems 2 and 3. Pause the video. When you're ready to review your answers, press play and I will show you, I will give you your answers for you to check your work. Thank you for pausing your video. For number 2, you should have got the number times itself 5 times is 2. 2 times 2 times 2 times 2 times 2 gets you 32. So the 5th root of 32 is 2. Okay, number 3, the number is 5. So 5 times 5 times 5 times 5, 4 5s is 625. Now, we want to really focus in on what do we do when we have an exponent that is a fraction. Here's what we do when the exponent is a fraction. You take this 2, this 2 becomes that number right here outside of your radical. So this can be simplified, remember you're focusing on that simplify, to the square root of 49. Another remember is we don't usually write that 2 when we write down the square root. It's already implied that that says 2. Okay, so what times itself twice gets us 49, and we know the number is 7. All right, pause your video, try problems number 5 and 6. When you're ready to go over your answers, press play, and I will work through them really quickly with you. All right, thanks for pausing your video. Number 5, we're going to take that 3 right here, and it's going to go outside of our radical. 343 goes inside, so what times itself 3 times gets us 343. The answer to that is also 7. The number is 7. All right, 6 is going to go outside the radical. So what times itself 6 times, make sure I get 6 in there, gets us 64. The answer to number 6, the number is 2. All right, now we're going to go and bump this simplification up. Most of the time you won't have radicals that are 1 over 3 or 1 over 2 or 1 over 4. Most of the time you will see that the exponent is a rational number, a fractional number, and here's how you go through and simplify and then evaluate. All right, number 7, 3 will still be the outside of your radical. 64 will still go inside, but after you're done finding the cube root of 64, you're going to square that answer. So this 2 goes outside and stays as a squaring exponent. Okay, the reason this happens is, and don't write this next part down, it's just a proof. I'm just going to go through with an example that we started to learn about. That power of powers property is because 64 to the 2/3 can also be written, and it means the same thing as 64 to the 1/3 squared. When you have this 1/3 squared, you go through and you multiply that 1/3 and 2. That's that power of powers property. And 1/3 times 2 is 2/3. So your exponent can stay as 2/3. All right, what do you do after this? You follow your order of operations. What is the cube root of 64? The cube root of 64 is 4. And then 4 squared is 16. So the answer to number 7 is 16. Go ahead and pause your video. Come back to 8 and 9 when you're ready to go over your answers. Thank you for pausing your videos. Let's go ahead and go over 8 and 9. So 8 should have the square root of 9. Remember, we don't write that 2 there, it's already implied. And then we're going to raise that to the 5th exponent. Okay, what is the square root of 9? 3. 3 to the 5th exponent happens to be 243. The answer to number 8 is 243. Good morning. Last, number 9. Number 9 can be simplified to the 4th root of 256 cubed. Okay, 256. What number times itself 4 times is 256? That's 4. So 4 cubed is going to be 64. All right, go ahead and answer this essential question. And then go take that checkpoint so I can and Mr. Isles can see how you're doing. All right, have a good night, guys. Bye.